Now, we've seen some situations where we were able to look at some limits and figure out what those limits looked like they were. So what I want to do now is look at a situation where the limit is undefined, where the limit doesn't exist, because it's not always true that we're going to get a nice number out for the limit. And I think it's important early on in our exploration of limits to see an example like that. So what I want us to do is to consider the function f of x equals x over the absolute value of x near x equals 0. Now, if we make a table of values for this, let's first start with some positive values. We want to look at what happens near x equals 0. So we can look at 1, 0.5, 0.1, 0.01, 0.001, let's say. Now, when x equals 1, that's going to be 1 over the absolute value of 1, which of course is 1, and then 1 over 1 is 1, so f of x is 1. When x is 0.5, we've got 0.5 over the absolute value of 0.5, and of course the absolute value of 0.5 is 0.5, so we've got 0.5 over 0.5, which is also equal to 1. If we plug in 0.1, we're going to end up with the same thing. Because when x is positive, the absolute value of x is just x itself. Right? When we take the absolute value of a positive number, it stays the same. So for positive values of x, this just becomes x, and x over x is 1. So in all of these cases, we're going to end up with 1. And so you might start to think, well, the limit is 1 then, if it's always 1. However, if we look at negative values, we end up with something different. Negative 1, negative 0.5, negative 0.1, etc. When we take the absolute value of a negative number, it becomes positive. So whenever we're plugging in a negative, we end up with a negative divided by a positive, which ends up being negative. So all of these are going to be negative. And in fact, they're all going to be negative 1, right? If we pick negative 1, for example, and plug it in, that's going to be negative 1 over positive 1. The absolute value makes it positive. And negative 1 divided by positive 1 is negative 1. Similarly, negative 0.5 divided by positive 0.5 is negative 1. All of these are negative 1. So in essence, in fact, we can draw a quick sketch of what the graph of this function looks like. For all of the positive values of x, it is equal to 1, this function. It's undefined at 0, because we can't divide by 0. And then for all the negative values, the function's equal to negative 1. So this is what the graph of this function looks like. And you can see that we have kind of different behavior on the right and on the left. There is a jump discontinuity, meaning the graph jumps from one point to another. And in this situation, we're not getting closer and closer to the same number on both sides. So that means the limit does not exist. So we can say the limit as x approaches 0 of x over the absolute value of x does not exist. Sometimes you write DNE for does not exist. So this is a situation where we have a limit that doesn't exist. And there are many situations we will see where that happens to be the case.